And we are live. All right, this is going to be the angle measure in right triangle trig homework help video. We start with a couple of problems that ask us to convert each degree measure into radians and each radian measure into degrees. In order to do this, we need to memorize one conversion ratio, and then we'll just use it to convert everything else. The one that I want you to memorize is the fact that 180 degrees is equal to pi radians. All right, 180 degrees, that's a straight line. Pi radians, this is a pretty simple radian. So hopefully we can remember just this simple ratio that's true, and then we'll use it to convert everything else. For example, this one here, I can multiply it by pi over 180 degrees. This is a form of 1, so it's not going to change the value. Pi is equal to 180 degrees. But now, since degrees is on the top and the bottom, it'll cancel out, and I'll be left with 120 pi over 180. Those are both divisible by 60, leaving us with 2 pi over 3. And I'm going to say rad for radians. Radians is unitless, but we still write rad to remind us that this is connected to angle measure. Let's do one starting with radians here, negative 19 pi over 6. So this time I'm going to multiply it not by pi over 180 degrees, but if pi is on top, I'm just going to flip this conversion ratio over. So now the pi's will cancel out, and I'm left with 19 times 180. Let me get my trusty calculator out. 19 times 180, 3,420, make it negative, divided by 6, and then this degree measurement is still sticking around. Let's see if that divides evenly by 6. I'm pretty sure it will. Yes, it does. So that's negative 570 degrees. The little circle is pretty important so we don't confuse it with radians. All right, find the measure of each angle. If the reference angle is given in radians, give your answer in radians. If the reference angle is given in degrees, then give your answer in degrees. All right, this reference angle here is clearly in radians. We can tell that because most radian measurements have a pi in them, and we don't see that little circle that tells us that this is degrees. All right, we're going to ignore positive versus negative to start, and then we'll remember it at the very end. I'm just going to count rotations, and either way that we're going, I'm just going to count them positively as not to like add in an extra layer of confusion. So my arrow starts here. My initial side was here. And then as I started rotating that terminal side around, it follows the path of this arrow. Let's count out loud the degrees as we go around. That's 180. Or actually, we're in radians, so that's pi radians. A full revolution is 2 pi radians. But now how much further does it have to go here? Well, a full rotation would be pi, but it gets stopped 2 pi over 3 short. This here, let me actually do the fractions. That pi, I'm going to multiply it by 3 over 3. So I can get a common denominator. So now I've got 3 pi over 3 minus 2 pi over 3. That there is equal to pi over 3, or 1 pi over 3. And then we're going to add that to the 2 pi, but I'm going to convert this by multiplying it by 3 over 3. So now I've got 6 pi over 3 plus pi over 3. This rotation here is 7 pi over 3. All right. Let's take a look at one that's done in degrees. Like, yeah, we'll do number 7 because that's also a negative rotation. Number 5 here was a positive rotation. We're going counterclockwise, that's positive. Another way to remember is just from that initial side, our first move is up, so we know it's positive. All right, look at number 7. This one's going to end up being negative. We can tell that it's going clockwise, which means negative. Also, the first move here is down, which kind of reminds us that it's negative. This one's given in degrees, so we're going to count in degrees as we go around. This is 180. So we keep going. A full revolution is 360. This is a 540, a 720. Add another 180 when we hit a 900. So it's 900 up to there. Up to here is going to be 990. Part of this final angle. We don't have to calculate anything. We just got to add in that 70. 990 plus 70 gives us our final answer of 1060 degrees. All right. Let's move on. State if the given angles are coterminal. If they are coterminal, if they are, their difference will be evenly divisible by 360 degrees. And it doesn't matter which way you subtract them. I'll subtract these ones the normal way, or the normal way, just smaller from the bigger. And I'm going to get that is 360. 360 divided by 360 is 1. That's an integer, so this is a yes. These are indeed coterminal. If I do 140 minus a negative 500, that's going to give me a positive 640. Is that divisible by 360? It's going to give me a decimal. So this is a decimal. So these, no, number 14 is, those are not coterminal angles. Angles with the same terminal side. All right, I tossed some right triangle trig in here, just so you guys would get some practice with that. Let's just pull one problem out from each section. I'll solve from X here. So this is my reference angle theta. I'm going to label everything based off theta. That would make this side over here the opposite. This side here the adjacent. This side here the hypotenuse. I have adjacent. I want opposite. That means I'm using tangent. So the tangent of 53 degrees should be equal to my opposite, which is x, divided by the adjacent, which is 8. Multiply both sides by 8. So I'm going to get 8 tan 53 equals x. This is approximately, get out my calculator again. Let's see, tangent of 53 times 8, 10.61 units. Let's look at some of these where we're solving for the angle. We'll do number 21. I still label my sides based on that angle. This would still be the opposite. This would still be the adjacent. This is still the hypotenuse. I've got opposite and adjacent. That means I'm using tangent. But I'm just going to do the tangent of theta. I don't know theta, so I'll just leave it as theta. The tangent of theta equals the opposite over adjacent, or 10 over 12. To keep going now, I have to do the inverse tangent. That's what's going to finally free up my angle inside there. I can get the angle by itself. So theta is equal to And let me just show this actually on the calculator. Let's see where the buttons are. One second. All right, so I want to do the inverse tangent. So I do second tangent of, and I can just plug this in as 10 divided by 12. I don't have to simplify that to 5/6 or anything. I'm going to enter 39.8. That makes sense. Let me double check my calculator is in degree mode. It is. You can see there. All I had to do is press the mode button and then look down here. That degree was highlighted and not radian. So now I'm more confident that is the correct answer, 39.8 degrees. So 39.8 degrees. And now we know how to convert that into radians if we want radians for that measurement. All right, we'll call that good for this homework help video. Hopefully it's been helpful. See you in class.